Just a second. Just a second. I think now it's better and it's not so loud. So, good afternoon everyone, and welcome to our traditional LinkedIn live stream. And just one more double check as usual, because of lots of things which are happening around, and this is one of the reasons why we are starting actually 41 minutes later than it was expected. And but at the same time, I hope that this experience which you will get today will be interesting and useful in terms of practical application for your specific plant nursery or any other type of businesses which you are doing. So let's start straight to the point, to the germination counting, and maybe then when we will have time we will consider other points. And this is actually the reason, because I prepared so many things. I want to show you exactly now what we will have today, what I have prepared at least, and then maybe we will, if it will take so long, maybe we'll just do the second part next time. But this is what I have. I have presentation, also I have demonstration, and also I have mobile demonstration. So you see, it's kind of lots of things which need to be connected, and that's why 41 minutes late. Anyway, let's go to our main point regarding germination counting. And as just a reminder, last time we have done another point which was a little bit related to germination count. We were analyzing the newsletter about the plant detection, and as I mentioned, this is one of the parts of the germination count funnel, if you will suggest it in that way. And that's why I want to mention as well that germination count, it's not just about numbers, and this is our presentation about. So germination count, it's actually, just a second, I will open the right document. I think this one, no? Where is it? Ah, here, okay. So yeah, just as I mentioned, you know, many screens don't know where to look. So germination count, as we already mentioned, it's not just about the numbers which you will get automatically because the algorithm is trained so good and it can do it automatically. We are creating this knowledge about the germination rate in order to get understanding about how the plants are developing, but not only this kind of information. And by the way, regarding the flow of our today's live stream, we will firstly look at this presentation, a little bit theoretical, a little bit maybe further picture of what's the reason of germination counting and why we are doing it. And then on later part we will look at these these demonstrations which we have already run on local device. Yes, it's one of the how the AI can work on edge. So we have it run specifically on the device now, and also we will have this mobile application, but everything will be in order. So, and yes, one more remark regarding this presentation. I know that sometimes it looks a little bit unusual in terms of colors and the representation of the biological objects or some other quite scientific and maybe not so clearly visible demonstrated objects, but please forgive, this is the creative level of AI side. So we have created this nice presentation together with my AI assistant, so sometimes we need to make this creativity wrapped in more rules, and next time I hope it will be more clear in terms of visual representation what exactly is hidden behind this very beautiful stain of green and red color, but at least you understand that we are speaking about some interesting process which we actually can see it if we will go in that micro level. At the same time, for most of the cases, we are just speaking about the seed, and then we put it into the soil, and then we have the germination process, which we need to count the results of this process. So this is kind of how the AI assistant see this. And the next point, which is important in this slide, just a second here. So, not too fast, yes. So, the next thing what is important is about the, as I mentioned, it's not just purely numbers, because obviously if we speak about the financial side of business for plant nursery, it's about numbers. But if we speak about the overall understanding and immerging yourself into this the environment of growing plants and make it in a more efficient way, there is a need to understand why we are doing something, and this germination count can be the sign which can be treated differently, and it can be translated differently. And one of the important aspects of why we are counting the germination rate is that it's not just about plants. As I mentioned, it's also sometimes covering the other side, which is purely non-plant side. It's about the nursery conditions where we grow these plants, and specifically you can see the list of operational roadblocks which exist, and depending on the presence of these roadblocks or absence of them or variability in them, the germination rate of the seedlings can be different, and this is actually the points where you can intervene and impact the further processes. So basically, what does this mean? For example, you have the plant tray with seedlings, and you have the germination rate like 75%. So one of the obvious reasons is about the quality of seeds. And on later stage, we will also look at the, not today obviously because we are overloaded with the germination rate, but I mean that we still have the other AI opportunity to assess the seed status, as well as the quality assessment, do the quality assessment of seeds. And this is one of the points which are important when you are thinking about the germination rate, why it's so low. But other part of this story is about the conditions, and for example, if growing media or the temperature is not appropriate, or there is not proper irrigation, or there is no proper other parts of the protocol which you need to follow, but you don't do this, the result is 75 or even less % of germination. At the same time, there is another thing which is always a comparison. So and this is actually the beauty of experiment, and when you are just trying to understand, because obviously if some biological objects is put in perfect conditions, then it starts to grow and do it very nicely, and everything is okay. But the only problem that to make the conditions perfect, you need to contribute, you need to invest a lot of money. I will not try to say that you need to do like a lot of efforts of humans and time, because everything is lead to money which you are spending for your labor, for your agronomical, for your agricultural inputs and other parts, but everything is equal to money which you spend to make this environment proper. And that's why you can always make this maximum amount of investments. At the same time, we know that it's still possible to adjust the environment and still get very acceptable results. So this is where the experimenting comes in, and the more we work with the growers, specifically with plant nursery owners, the more we see that there is a space, there is a window for this experimenting, and that's why it's always possible to achieve the good germination rate above 90-95%, even without that maximum input, which is kind prescribed by doctor, let's say. And on one stage, I think we still need to do maybe one more live stream regarding the germination rate, because today we will speak about overall tasks, and you will see how it works, but also we have opportunity to show, I think it's not covered by NDA, but I need to double check. As I mentioned, there are the plant nursery owners, they are trying to optimize how to work with different size of trays, different amount of plants which are sown, and also different amount of seeds which are sown, and also other like live hacks, how to make business going and still get the good results. So it will be maybe kind of practical insights of not just about AI, but also about how AI can support this experimenting in fruitful way. Also, regarding the measurements, as I mentioned, it's one of the goals why we're here today, but not only. So we, based on this, based on the measurements, we can based on the count, we also can think about the characteristics of the seedlings. And this is again the practical side, when we were on some stage asked not just about the germination rate as purely number, but also assessment of viability of seedlings and also uniformity. One of the ways how the uniformity was suggested to measure, because we then switched this direction and we done another part, but this is where the leaf area actually works, because on the smallest stage, when the plants are still small, it's possible to do this count, but on later stage, as well as for some crops which have a bigger canopy and they are already overlapping, and even for some, let's remember last time we spoke about the strawberries, and when we had two mother plants in the same pot, it just by the way, it's one of the methods how to optimize the space when you can use the same pot for two plants simultaneously. But the problem last time was when we had this automatic identification of automatic detection of plants, the overlapping of the leaves, and then you just don't understand which plant is. So the same situation is with germination count, so it should be done on specific stage of plant development. In other situation, it will be just a challenge to identify the borders of the cells, and as a result it will be the accuracy problems. And by the way, I will show you some accuracy problems even today. I hope we will have time. And what's next? This was previous. This is, yes, just one more creative way how to demonstrate the the opportunity behind automatic germination count, and what's also can be yes, what are the systematic indicators, and yeah, nice demonstration of spatial patterns about map operational failures, which can lead to uneven germination in the tray. But as I mentioned, this can be detected and analyzed on later stage when the plants are already present, because what we see, and also it depends on the again standard operating procedure of specific plant nursery, that for some plant nurseries they are starting to count seedlings like on a specific day, but there is the chance that not all the seedlings have been emerged. So there is and this kind of one of the practical bottlenecks which we met, because we got imagery from the plant nursery, and what we have seen is just the holes, and that's it, and there were just a few of seedlings which were emerged. At the same time, when we then tried to identify what's the problem, we understood that it was too early to do the counting, because obviously there is a biological time when the seedlings has still this time, and they are not late emerged, considered as late. So that's why we suggest that it should not be like that stage when you just put the seeds and then next day you're trying to understand what is the germination rate. So it should be some and again, it's in practical side, it's better to do it one time when most of the seedlings are already emerged, rather than doing it on like 3 times and getting +1 seedling every day. So that's why it should be embedded into the operations in a nice way. Even it's automatically, but it still should not be a waste of resources on the both sides, on the side of grower and on the side of the processing team of the imagery. Yes, we haven't seen this slide yet. So, and this is kind like of the one of the main messages which I mentioned already at the beginning, that germination is not just about understanding the rate, it's kind of the test of the whole system which exists for propagating the plants. And obviously we can, last time when I was doing this newsletter about the strawberry plants, and we got some comments, so thank you so much, Dr. Taras Pasternak, for your comment, and it was a question. And I believe that on one day we will have the proper dialogue and conversation, and it will be a dive into the propagation processes, because obviously it's a separate story, and a separate huge story. So we can do even not just one, but a few of the conversations, how it's possible to do the to check this propagation system using these kind of small use cases when you are doing numbers, and these numbers show something. So these numbers can be a proof of either very good built system for propagating plants or not very good, and then you can understand what's wrong. And if you go back, you see oh no, it's not go back, it's go forward, and on the left hand side, oh sorry, on the right hand side, you can see the explanation of indicators and paths which can go into failure, and this can significantly impact the propagation pipeline. Have we done this? Yes, I think so. Yes, sorry for this a little bit messy change of the slides. Regarding the comparison, I think it has been already discussed many times, but we still need just a quick reminder that manual versus non-manual, let's say automatic or AI powered or digital, or call it whatever you like. But I mean that what we have when the human is counting, it's still, yes, we still have the human into this rightest path, because again and again we will continue to repeat this, that humans will not be substituted with AI, just because the AI systems, they need to be verified. And this is the concept called human in the loop, and it's very important because again, when I will do demonstration today, the results which we are getting from the machine learning model, which is analyzing the content of each cells, it should be verified. And because sometimes the biology behind any seedling is unpredictable, so some seedlings may not look like seedlings, and again the algorithms sometimes behave not in accordance with the plan. So these awkward situations happen. So that's why human is always the authority which is saying, do we have the proper counting, or have we counted some objects which should not be considered as the seedlings? And this is the main part where the human is responsible and absolutely relevant. At the same time, when we are speaking about this purely manual and human-based counting of seedlings, and specifically for a huge amount of trays, when we speak about like 20, or when we speak about these gutters with 20 meters, and you have these seedlings which have been emerged, and you just need to do them, and you have these dozens of gutters, not just one. This is where the human abilities to be effective are limited, and that's why the introduction of automatic data collection as well as automatic analysis of imagery is helpful. And this is how the collaboration of AI systems and human capabilities looks like. So it's like human is still because again, another point regarding the data collection, in bright future and somewhere maybe already in Mars, or I don't know, somewhere else, there is a system which is robot which is going and collecting data, and human is just controlling. But in our reality on Earth and what's going on in real plant nurseries and growing systems, it's not just plant nurseries but in farms sometimes, it's still human who is doing the data collection. But then after data collection, there is a point where the AI brain can be included. And this is kind of the most real boost of productivity for plant nursery in terms of germination assessment. So what I mean that the human have collected this data, then it can be the automatic upload, or sometimes it can be done on device. So there are plenty of opportunities how the analysis may look like. And the next point is when the algorithm has already counted, and then the initial results are provided, and then the human step again into the game, and the human is starting to assess how correct or how many errors has been done by the algorithm. And again, we are speaking about the continuous learning and relearning. And yes, there is another way that we need to speak, that it's teaching and reteaching the algorithm. So based on the detection, false detection which has been discovered by the human, it's possible to teach the system what was wrong on the previous time, and next time these errors will be excluded from the results. So the more we learn, the better the outcome is. But again, this process is based on some data which has specific features, and they are existing only for this data set. Because the more you put data into this pipeline, if it's different data, it will not make any sense. But because yes, let's even say if you, depending what you are building, but if you are working with specific farm, you are growing specific type of crop, and this crop looks approximately in the same manner, so there is no way and no need in practical side to teach the algorithm how like crop from another country looks like, because you will never use it in practice. But practically it's important to feed your algorithm with more relevant data, and then the accuracy is improving, and then you get the results, and you are more happy with what you get from the AI-based germination count. And yes, another point, every pixel is negotiation, but this is where I want to mention regarding the growing medium and how it's important, because this is what, again, from the practice, that sometimes it's very easy to detect the plants in the tray, but sometimes it's very difficult. And this is the point where, as I mentioned, local and specific data sets are important just to make this good training, and based on it you can negotiate every pixel. Is it still plant, or it's already growing medium? And I think on one stage I will show you one of the challenging cases, because I remember it's not covered by NDA, and even I have shown it in one of the I asked AI. So there was kind of 3 seedlings, and they were so narrow, their leaves were very small and narrow, so and the growing medium was quite interesting in terms of the texture, because there were some white small pebbles, and because of presence of these very narrow leaves and white pebbles, the overall view of the tray was a little bit over. So you need to spend really some huge amount of time to understand. Specifically, they had the trays like 7x12, so it was 84 cells. And when there's 84 cells, you have just counted, and you understand that you need to check the photo, another one, and so it's human. For human, it's still not the easiest task, but for algorithm, since we have developed and adjusted it for this specific look of growing media and this specific look of seedlings in these conditions, it was acceptable. And yes, another point is about the trays, and I think where is it? Yes, because I have obviously this tray. I will show you something later on if I will not forget, but I have another here as well. Just a second. Yeah, I have plenty of trays. Yeah, another trays. What I mean that again, the architecture of these trays are different, so depending on where the cells are, how the cells look like, how the growing medium is, what is the appearance of the crop. So there are so many variables, and then actual look, it's kind of, again, 1 million variations. This makes sense to automate. Yes, and let's move on. And this, I really like this kind of diagram because we are on the stage 1, I think. Yes? Oh, no, not stage 1, but between the first and the third stage. So depending on the crop and the actual task which we have. But I mean that still, based on this, we can move on, and then it's possible to do the other assessments. But germination rate, this is actually the first traditional task which we have started to work with growers, with real growers, because we have worked for more than 10 years with scientists who are doing different type of tasks and use cases. At the same time, when we think about this production cycle, then germination rate counting is one of the germination rate assessment is one of the main practically important tasks which can be automated using AI. And another point is about the so-called edge cases, or here on this slide they're called abnormalities. And the topic of abnormalities can be huge and interesting because we have, and it's not again only about the germination rate. We can speak about the abnormalities in other type of detection. And last time we also mentioned this point that if the plant looks differently rather than traditional look, it's possible that we will have some error related to this specific plant detection. And regarding abnormalities, in practical side, what I can reference immediately, on one stage we were asking to count this germination rate for plants, and then what we saw that in the seedling, in the tray, some cells have not one, because in most cells there were one plant, one seedling per cell, and some cells had 2 seedlings per cell. And it was it's possible still to consider if we think about germinated or non-germinated. So is a 1 or 0? It's definitely 1. At the same time, when the challenge is to count them, then we need to think about that this 1 actually means 2, because we have 2 seedlings and it's clearly visible that they have more leaves than other seedlings in the same tray. So, but we just re-asked the grower, and they confirmed that they just want to consider even 2 seedlings as 1 seedling. So these abnormalities, it's kind adjustable depending on what is the final goal of grower is. But again, this was our task to explain to the algorithm that for the job of counting, you need to understand that this even detected 2 plants in the same cell should be counted as 1 plant. So, you know, it's kind of extra 50 lines of code which can say this to the machine. Let's call it like that. And yes, this is kind of like the step number 1 which we will do today. And then based on this step number 1 establishment, you can go up and up to the final point of everything else, like dynamics, morphology, health, uniformity, and prediction. At the same time, I think we can just wrap up our presentation because it's kind of very interesting. At the same time, I believe, and this is the final slide, I believe that practical side of germination count will be more excited. So let's just try to do this. And yeah, it's kind of a bit poetic that the first signal in the life of a batch is this germination. And let's look how it will work in real tasks and how the germination count looks like. So let's start with this one. What do we have here? First of all, it's the AI model for germination count, which is run on device. Just one more second. I will open it on my side. On my side, one more thing. Oh yeah, I see it. I see it here. So sorry, I will just sometimes go up to be able to show you. And just one more thing. I do apologize about this kind a little bit unprepared moments, but this is the point of live streams. So when you have everything ongoing. And as I mentioned, this is the reason why I was late for 41 minutes. And in the university, maybe since we are now in different countries, some of you are in one country, I'm in another country, but I mean that when I went to university, we had the rule that 45 minutes, kind of like a lecture, and if the lecturer is late for 15 minutes, we are able to leave the room and we will not have any consequences, negative, you know, for students. Yeah, in my case, it was 41 minutes of being late. So I do apologize about that, first of all, but another point that I am so grateful to LinkedIn, because they have this flexible understanding that people are sometimes busy, sometimes technologies are not working straightforward as expected, and sometimes just a matter of business routine that sometimes there is a very urgent case which you just need to finish it, and then you are starting your live stream. So yes, I am truly appreciated to all the platforms where I have live streams, because they are all very supportive to people like me who are trying to do something. Yeah, and demonstrate it in live mode, because yes, so I hope it will not fail now, this system, which is it's not fragile, because we actually tried it in different environment and it was working, but in this exactly this setup for live stream, it works first time. So I don't know, will it work or not? So that's why. But what I mean, that this is exactly the example of edge AI, because just imagine I'm staying not here, but in the farm, in the plant nursery, in some growing room, and then I have this laptop, and then I have a camera, and then or even not a camera, I can even collect with a smartphone, just take a smartphone, take photos, and then come to my computer, have this imagery uploaded into the drive, and as a result, I can do this assessment. And for example, so what we have here, because the model is run, do you see it? Yes, it's like if you see the browser line here on the top, the address. So 0.0.0 and 7860, it means that we are on local host. So we are not going anywhere, and I can do it without internet. Obviously, I cannot show it without internet because our live stream is on internet. But I mean that my model is running exactly on my laptop. And we discovered that this type of work is good for some of the growers, specifically when they are in rural areas, because they don't have the connection, a proper level of connection. Specifically, if we think about the sending some huge amount of data to the cloud and processing it and then coming, getting back the results. So first of all, it's time consuming. Second time, sometimes the internet is paid, so it's kind of money consuming, financially unstable model. And the third thing is about the data privacy. It's one of the things which are not such a huge discussion in agriculture, but it's actually important because on some stage I already referenced to this point that data is a currency of the future. So you need to be very attentive to not just for your private data and personal data. You know already who is using your personal data. We will not focus on this in this live stream, but I mean that farm data is one of the possibilities for you, and that's why if you can, or again, you just need to clearly discuss the relationship regarding data with your data processing company or the company which is providing you any type of AI powered support. So yes, and it's a separate topic. We will cover. It's covered a little bit in my course. I mean, this Udemy course called AI in Agriculture, Practical Introductory Course. And yes, there will be an update soon. And another point, if you are waiting for the certificates for this course, please give me just 2 more weeks and I will send you certificates. It's just about a matter of time, so I do apologize about the delays. Regarding the data, so if you are running on your local device, all your data stays with you and it's not traveling anywhere else. So this is the brilliance of working on Edge AI, but Edge AI can be different. But I mean, like the how to say, the edge case of Edge AI, when you are just saving your data, running your model, doing everything on your device. This is the final bit. There is a little bit different story when you can still work on your device, but there are some you still need to do something in the internet, or there is the configuration can be different. But in my case, currently we are speaking about Edge AI in fullest mode, when the data is local, the model is running on a local device, and everything stays with me. Yes, and another point just to mention, sovereign AI. It will be one of future live streams, how sovereign AI can be implemented into agriculture. But that's it, because it's germination counting now. So, and yes, this is my... So what do we have here? We have here on the left-hand side, we have the input, and for input I can upload, or I can do the web camera, or I can do other. So we have suggested that there are different methods. I'm just not sure. You cannot see. Oh my God. Or you can see. I just can't understand. Is it moving or not properly? Maybe. Now it should be fine. It's not moving here. Oh my God. I don't want to have this shame again. I thought it's working. Window capture, just a second, because on my side it was working, and I see that you also can see the top of the browser, which says that we are doing the germination count. Okay, if it will be my problem, then we will jump to the mobile, because as I mentioned, we also have the mobile demonstration as well. At the same time, just give me a chance of fixing it maybe on the go. I just can do this, and germination samplings count. Yes, I am moving it, but why it's not here? Or maybe this one. Oh yes, that's it. Finally, I am saved. So this is what I have showed to you. And can I do the full screen? Just a second. I remember this hotkeys here. Is it? Just a second, because yeah, as I mentioned, my traditional. Forgive me, please. There are Windows, there is Mac, and there is Linux. So I traditionally work in Windows and Linux, but sometimes I need to work here with this MacBook, and they have different setup of hotkeys. And I don't remember how to do this full screen in MacBook. So I remember I need to press function, but just a second, and then we will go to this demonstration, because I believe it's nice to have this nice demonstration. Ctrl plus F. Okay, Ctrl plus F. Yes, now it's much better, I believe, or not. Do we have the change or not? It's not moving again. Give me a second, please. I will just try to understand why it's not moving. Why I was trying to fix the full screen, something happened, and now I see that it's still no, it's not working. This one? Oh my god, sometimes it's better not to try to make something better, because I wanted this full screen mode and now it's not working again. Okay, let's go back. Command Control F. No. Control F. Yes, this is kind of preparating part of full demonstration how the system works on the local device, and since we in live mode, everything happens. No, okay. So what can we do now? But I'm just curious. Yes, why it's not working again? Maybe just one more thing. Google Chrome. Yeah, it's not the best demonstration, obviously. Okay, let's go to mobile. Maybe I will think in parallel how I can fix it, because this one was very interesting in terms of and again, visually it's nice to see, to demonstrate how it works, and it's kind of magic which happens straight here and now. Just one more thing, one more attempt. I do apologize. If you want to have a tea or something, yes, please just go and have your tea. But I will be so sad if it will not work anymore. So I know what I will do. Oh, I know. I will just remove it now fully, and then we'll add it one more time. So I will remove it now. Yes, I will remove it now, and now I will add it one more time, and let's see, will the magic work or not? Let's move it here, and now what we do, we are selecting the window, and the window is this one. Okay, I will not change the size, so please let's just follow. Since it's working good. So germination counter. What I wanted, I believe you can see my pointer. So the main thing is that, oh no, maybe you're not. It's only for me. But okay, you can see on the right hand side, it's left hand side, you can see there is a way how, specifically below the image, there is a way how to add the photos. So this is one of the things which you can either upload through the already existing photos, or another which is kind of central. And next time I will prepare, so I will have this pointer which will be showing the specific point which I mentioned. But as you see, I'm so happy that at least it's working in that way. There is a point where you can add the camera. So, and the basics is that if you have this this model on the device, and then you have camera, stable camera, forgot how it's called, oh my god, but I mean it's not moving, but it's specific, and it stays in the same point. You can collect imagery through this camera, because if I will switch on now, it will be the web camera obviously, but I will not do this because it will interrupt the way of this video streaming. But I mean that there are two ways how you can collect data, either already collected, or you can collect it through the camera, which is attached to this device, to this laptop. And then based on this, you can just bring the tray, take a photo and have a next one. It can be a conveyor belt as well if you have it. But I mean that there is flexibility of data collection. And again, when we have either standalone camera or collecting data using the mobile, the light can be set in proper way, so the full tray is lined, and you can see the properly all the cells at the edges, specifically because edges are always like a challenge. Anyway, so we have these examples, and then as you see, we have these ArUco markers on the tray. So basically this is the tray which we are speaking about. It's 200, I will even show you like that, 240 cells. So how it works, you can just, and you have these ArUco markers, so you just place in the ArUco marker on the top left, top right, and down left, down right. So you're just placing the ArUco marker like here, and that's it. It helps to automatically show the borders, how the system can identify the tray if it's in front of you. So I will show you even now. No, not now. I will not show. I just don't want to touch this system. But when we will have the mobile demonstration, I will show you. As you can see, the tray has these ArUco markers placed on the corners, and this helps to see the tray and separate this specific tray from others, because as you see, there are more than one, and this is how you can quickly adjust. Just place the markers, take a photo, place the markers, take a photo, and it takes this routine. It's kind of quick because especially when you are doing it like a few already days, you know how to place them, you know where to do this, so it makes the smooth data collection. And then you can upload the batch of these images for processing, and as a result it's a CSV file with also with captures of each cell, but we will see this now. So on the right hand side you can see the total cells, as I mentioned, 240, as well as the germinated cells. We have 223, empty cells 17, and we have automatically counted germination rate and average confidence. So just to remind, what is average confidence? It's kind how the algorithm is reassured that the counted results are true. And for example, if there is a seedling, and even if you will go down, there is the confidence level. You see this 1.2 zeros. It means that it's 100% true that the seedling is present. And even it looks like there are no, I see, for example, it looks like there are no seedlings in some specific cells. But if you will just try to look more attentively, you see that there is a seedling. And for example, we can also speak about this level of confidence 0.52 if we think about the lowest level. And these are the seedling, the cells which are non-germinated. At the same time, why the level of confidence is so low? Because there are still some objects in the cell. As you can see, they bring some assumptions that it possibly could be a seedling. So that's why there is no direct need to check this one which have 100% of confidence, but obviously if it's the case of 50-50 or even there can be 70% of accuracy and confidence, it's the point where the human has to come and check and say is it correct or not. So what we can do also, as you can see, the result summary is provided here, and apart from the cutouts which are done here, we also have yes, for batch processing the opportunity. We can save it if needed. So on the right hand side on the top one you can see the savings. Also we can see the other analytical part. So here is the empty cells only, and as you see, the one of the cells with ArUco marker was captured as the empty cell. At the same time, again, it's just a matter of learning. So for the next iteration, we can explain to the algorithm that these ArUco markers, they should be considered as empty cells at all, because we need to have 4 of them, not just 1. And then it will be, or maybe, because you know, if you know that there is a seedling below the ArUco marker, then you can just add +1 into the amount of germinated seedlings. Also, regarding the raw results, we provide it in this form, so it's possible to see the table of this chart. And again, it depends on the level of knowledge which you need to get, because some growers, they are pretty happy to have this CSV file and that's it. For some growers, there is a need for more. And also we, by the way, provide not just this type of visualization of the results, but also we provide this JSON file. You can just put it into whatever you need to process further on, even to your AI assistant if there is a pipeline of work with your AI assistants for this specific task. And finally, I want to show you that exports exist in different ways. So we have this PNG, CSV, and as we already seen, JSON. And here you can see the size of these possible export files. So just click and you will get the results downloaded. So let's try, and again this is a moment of unpredictable what will be next, because I have not tried it in live stream mode. As I mentioned, all these failures which you can see, specifically now when I am not able to switch the screens, when it's in private mode and I'm just switching the screens and everything works so smoothly, I'm so happy that, oh my god, we can have such a smooth way of live stream. And then as you see, anyway, so now our goal is to show how the real analysis works. So let's see how it will go. So we are clearing the results. Now we have nothing, and then we are choosing this or this. Let's choose another one, so it will be more interesting. At least you will see a little bit different angle of tray. And now, fingers crossed, run analysis. And this is where my computer is starting to work hard. You cannot hear it, but it's working really hard now, because as you see, it's classifying cells and doing all the jobs which we asked from him. And now everything is done. So let's see what do we have. So we have total cells, and we have 230 samplings, and also we have empty cells 10. And by the way, visualization of empty cells are orange dots, so we can see them in this way. And this is that full screen, which I hope I will be able to come back and it will not be broken. Because on my side, as you see, sometimes it happens. So you see the results here, and in our case, even 3 of the ArUco markers, the top one are classified as non-germinated, and we can see the orange dots. On the other hand, we can see other, for example, this here. You can just visually assess, is it correct or not correct. Orange means empty cells. Now let's go back. Yes. And what else do we have? So we have higher germination rate, 95.8. But let's also, and we already started from exports, but let's see the saplings. And this is the, again, we have our only one, as you can see, was, and again, the level of confidence is 0.74. It means that algorithm is still not sure that it should be considered as germinated seedling. So that's why, obviously, for the next iteration and round of learning, we will explain that it should be. And you know why? Because if you will look at this specific cell, there is a bit of green, some like piece of leaf which is captured. So maybe this part of green line was considered as a part of the germinated cell, because if we will check the other cells which are empty, so here we have our three cells with ArUco markers, which we consider as empty because there are no green lines at all. But with this one, which is, as you can see, 74% of confidence, it's still a little bit something green. So this may be the reason why it was considered as the germinated. And this is where the human, unfortunately, I cannot just take the ArUco marker and just understand is there seedling or not. But if you have been there, you can just remember what was there a seedling or not. Or again, it's possible if you are on site, you can just go and double check, because all these trays, they have the identification. So with this grower, we don't have the automatic barcode reading, but with other grower, we have the full cycle. When the person who is doing photo, it's possible also to do this automatic barcode reading, because they are using barcodes which are automatically printed and sticked on each tray. So that's why, as you see, there is a next level of progression when you can get the identification of the tray, and then you can automation of germination rate, and it's again linked to the ID, linked to the results. So I think it's, as of now, it's clear, and yes, this is kind of the case as well. I see just in general that it's good in visual terms. So the green seedlings are visible on the dark growing media. At the same time, I believe that due to time reasons, we will not look at the other case of plant nursery for fir trees when the growing media was different color. Maybe on one of the next parts of this series of Germination Count, we will look at them. And just to repeat that we have empty cells and row numbers here. And also as you can see, the predicted class is one of the points where you can just quickly scroll and see, do we have any? Yes, here, for example, it's considered as soil inside, not a sapling. So yes, and again, you can just check each row, and specifically, as you see, the logic, how the algorithm is considered. So it's the column number as well as, oh, just a second. Yeah, it's a column number as well as row number, and actually each row has, each cell has its own number. So having time, you can just double check using numbers and rows and imagery, but in quicker way, it's just possible to either use this as CSV or ask AI assistant to do instead of you. So just JSON file. And finally, exports we have seen. Yes, so I think it's the with this part we have done. And now let's go to the next part, which I already prepared. I hope it will also work nicely. So mobile, and this is kind the same photos, because again, just a quick reminder that with most of the collaborators and companies which we work with, we use the non-disclosure agreement, or it's also called confidentiality agreement. And this, why this is important, it makes our work with our collaborator in more trusted way, and this is how they are reassured that the information is not demonstrated on live streams. So this is why we are signing the confidentiality agreement, because we know that everything we have shared with them stays in private mode between us, and they know the same. But this information which I am showing you now, it's we decided with the company that it's open, it's possible to share it publicly. So, and we are grateful for this opportunity to show how it works in reality. So now it's time for our smartphone part. And again, I'm just thinking how to do it in a more efficient way, because we have plenty of things to do here. But first of all, just until I remember and I have not forgotten, I will show you how the tray with the with the ArUco markers look like. So now I will just switch on the camera so you can see now everything, and then I will just show you like this. So you can see this is how the work of automatic work look like. You just add the ArUco marker in each corner, and automatic borders will be detected by the algorithm, because algorithm it knows where these markers are, and it means that this is the rectangle of the tray. Yes, and now let's just go, since we already have the imagery ready. So we are going, and today we are not using our traditional, our traditional calibrating plates we are not using, because for this task, when we don't need to count, to measure anything, we're just counting. For counting, it's possible to do without calibrating plate. And now we go to this germination count, which is like scroll a little bit from the top. And this is the germination counting. So what do we have here? We have here the first part, which is important. You need to create the organization, because when you will try to do it without organization, you will not be able to do this. As I mentioned, we have done it just to make a proper structure of work, and also it helps to save your experiments in one place, so you will see what I mean. Now let's just imagine we are creating an organization, so you will know the flow how to do it. So you just press and create organization. Now we can write the organization, org, and that's it. And also we will choose the type of organization. We have the company, the non-profit, university, classroom, government, or community. It's absolutely fine to choose just the right thing. So we are the company, so we create the company. And now you can see we have two already organization created. One is PTO, because I created it for myself earlier, and then the second one is organization. So now you know the flow of creating organization. But I will just go into the PTO because I've already been there, and here you can see it's kind of like technical part. So it's not for doing anything or changing anything, just for us some information regarding your account. But what you can do next, you can do the germination count. At the same time, sometimes you don't have the photo of proper trays. So you can go and take the example photos. The example photos are available, and here they are. So as you see, the same photos which we have checked during our web demo on the local device, you can get them here and try to play with them as well. So let's go back and just what do we need to do? We need to go to PTO, and now germination counting. We are pressing the germination counting, and then we can have the experiment added. This is the point which I mentioned, that sometimes you have different plants, different crops, and then you need to separate the information, specifically if you have, let's say, a few photos or a few dozens of photos, then you can have different experiments, and you are just pressing on top and you are adding experiment. And yes, you can choose the organization. Now I have two, so I will choose the PTO, and then I experiment number 1, and then create. So now we have a free space of creating for the experiment. And then what we can do, we can just go there and see that we are able to add the photos. And now what I want to say regarding photos which I will add now, I will add the same photos as we have worked with. So you will be able to see the and you can see other photos which we have seen last time with these blueberries and everything. So just give me a second, I will remember. This one probably will be the right one which I want to add. So as you see, the process is has started, and this is how the PTO is working. At the same time, what I want to show you is that here is the enlarged tray, and what else I want to say? I want to say that we don't have this type of tray which is 12 by 22, so we can change it. Or here we are pressing, so we are going out of the experiment and pressing it, and you can you can choose the size of your tray. And this is the basic. We have started with just one size, 12 by 20, but then we understood, and the growers asked that there are other sizes, so we just added extra. But later on we understood that even this is not enough, this 5 sizes available, but still we can choose this one because it's 12 by 20. So that's why we introduced the ArUco markers, and these ArUco markers, they automatically help to understand where the borders are, and that's why we believe that this way of using ArUco markers is much more productive in terms of automatic detection of the borders. So what's next? Next, let's go to this processing. Oh, there's something interesting here. Just a second. This is how the demo looks like. I'm just confused by that, because maybe it's kind of interesting, because today in the morning I was running it and it was like this, you see. So this is how the demo looks like. And earlier I also ran another one which is like this, but an unusual look of this kind. We will investigate what's going on, but it's definitely something, because even I cannot, as you see, I cannot go further and see the results, as I can do the same, for example, in this. Because this experiment I was done just before the live stream to understand that everything is all right. So what do we have here? We have here the automatic detection. As you can see, the borders are automatically drawn by blue line, and additionally you can just check the numbers. However, regarding this model, again, it's run on device here, and the accuracy of this model, it should be improved, because basically we developed it for a different crop, not for this specific one. But as I mentioned, unfortunately I cannot show that type of photos which were initially used for training this model. So that's why I just want to demonstrate you the capabilities that what's possible. And one more thing, you can also, if you are trying to understand is it alive or not, you just can go like that, and you will see the magnification glass, and you can double check each cell in terms of presence or absence of seedling. And this is not end, because we have one more thing. So regarding these numbers, I think we have covered it. But now it's phone. Yes, sometimes it happens with phone. What else I want to show you? Even if you don't have these ArUco markers, there is also an opportunity to adjust the borders. So I hope it will work now, because obviously it should be demonstrated in real life. Alive. I cannot show how I adjusted the borders on previous photos, because it's not the same feeling like I will do this now. So maybe just let's forget about this a little bit broken experiment. Let's do another one, and again it will be petiole, and it will be experiment number 2. And yes, we will have this again photo, but now we will take this one which is without markers. Am I right that this is without markers? Just give me a second, I will double check. No, it's still with markers. So now I will demonstrate you the functionality of how to delete. So there is delete the image. Now the image should be deleted. Yes, and we don't have image. Now let's stop again and try to find without markers. Because why I'm asking about that? Because this will be a way how I will adjust the borders by myself, and you will see this real experience. So I believe it should be maybe this one. Sorry, I just didn't use the right methodology. Yes, this one is without markers. So as you see, there are no markers on this tray today. So what can we do? We can adjust the borders manually, and now I will show you how to do this. So while the processing is on the way, we can just see, and here is the foundation of the cell detection. So we are trying to adjust the borders and find the corners, and for this purpose we have also this magnifying glass. Okay, so this is kind of like that. But the main goal must be that the main task must be that we need to have these white lines, white dashed lines, according to the actual place of seedling, or of the borders of the cells. So as you see, it's approximate but not perfect, so I will try to make it even more neat and according, because for example the top left corner is a little bit not in the right position, so I will do it like this, and maybe so just try to visually make it appropriate. So maybe like this. Oh, no, I see. So yes, it takes a little bit of time, but on the other hand, in comparison with the time which you need to spend in order to count, it may take less. So that's why, yeah, but I believe it should be like just a second. So, and again, this pipeline of adjusting the borders, it's not created for live streams, so that's why it's in live stream mode it may be a little bit bored, and yeah, it's definitely not the thing which is the most interesting and exciting, how to adjust the borders of seedling trays in a quick way. Yeah, and I still see that I am not very good in this. Maybe I'm just a little bit nervous because of this live stream mode. But at least you understand the methodology, that you just need to use these blue dots and adjust your corners appropriately. And then based on this adjustment, you can, by the way, we can, as I mentioned, we have different number of cells available. I mean, number of cells and rows available for assessment. Even let's just do it like that, and then you just need to update. That's it. So now the algorithm will work and it will process the imagery, and now you can see how the process goes, but obviously we will not wait until that time. You can check it, but what I mean by different sizes of trays, here we have this 12x22, and if we will add, I think you've already seen that, for example, I will add something other like that, for example, and then we can just try to adjust the size of this tray, so it will be a different, just a second. So here is the tray size when you can select, so you need just to have this group selected, and then you can select the sizes as well. And one more thing, that why experiments are important, because you can basically have the summary of all the photos which you have processed, and you can get the average numbers as well. But again, it's possible to adjust and customize. So if there is a need for your specific production cycle, oh, something happened. Yes, something happened with my phone. I think now it's frozen and it's not, just to show you that I have some message which says that it's the end of the live stream, because I see that lots of things has to be fixed, and I didn't show you all the points which I wanted to show you due to some limitations, but life is limited, as you know. But what I will show you what will be next time. Just give me a second. Next time will be potato. You see, it's potato. Maybe I will just go to my full screen. Here is potato, and we will do something with potato next time. For example, maybe we will do some leaf area measurement, as well as we'll show another existing opportunities with potato, and maybe even some newsletter about potato, because It's just a very nice crop, and probably I now will go and cook some potatoes just to prepare myself for the next live stream. Thank you so much for your attention. See you next time. On a Tuesday. I don't know what is the number of May, but it will be in May on Tuesday next week. Thank you. See you next time.